MCom, MSc Psychology, MBA, MA English, MPhil, PhD is an eminent academician and popularly known for his simplicity. He is qualified in state-level eligibility test in commerce conducted by Boylston University in the year 2000. He has completed chartered accountancy, intermediate examinations and one group of final examinations. His areas of specialization are financial management and marketing management. His academic services spans over the period of 25 years in teaching, which includes 20 years of research activities. Having started his career as lecturer, by his proactive and dedicated services in reputed colleges, he was elevated and served as a principal for 12 years. He has served as a Senate member of Periyar University, Salem. He has acted as the external examiner for the conduct of PhD public viva examination for 17 candidates. He has acted as a resource person for refresher course, research methodology course, faculty development program, NET/SLED coaching for paper 1 and paper 2 commerce conducted by various universities. He has acted as a resource person for more than 300 international and national conference, seminars, workshops, and webinars. He is motivational speaker and has served as a resource person for more than 160 motivational programs and conducted training programs on positive thinking, time management, memory techniques, and stress management. His research activities are: he has guided 5 PhD scholars and 22 MPhil scholars. He has published one book and more than 43 papers, articles in referred journals, edited books. He is a proud member of following academic forums and social organizations. He is a member of Board of Studies in various reputed higher educational institutions. He is a member of Research Advisory Committee, Amity University, Jharkhand. He is the external member of Research Advisory Committee, GS College of Commerce, Varda, Maharashtra. He is the Chief Advisor of CAP Research Forum, Naharkoil. He is being acting as the Secretary of Indian Accounting Association, Salem chapter. He has been serving as a member of editorial board, pre-review committee of reputed journals. He is the life member of Indian Academic Research Association, Trichy. He is a member of Indian Association for Social Services Research. His valuable contribution to the...
Thank you very much. Very good evening to all the wonderful participants. It gives me immense pleasure to act as the resource person for the 2-day national level workshop on data analysis using SPSS. See, today we are going to discuss about the parametric tests, and tomorrow we are going to discuss about the non-parametric tests. I think the data have already been shared to you. Have you all got the data?
Yes, sir.
Yes. Okay. Thank you very much. Before that, we should understand the difference between parametric tests and non-parametric tests. While applying the tests, we have to understand which type of tool is to be applied or which type of test is appropriate for performing a particular analysis. For that, we should be able to understand what is the difference between the parametric tests and non-parametric tests. You might have received a lot of information about parametric tests and non-parametric tests. Whatever it is, you just begin from today's
So we can't hear you.
Not audible, sir.
Am I audible now?
Yes, sir. Now you're audible, sir.
Okay, okay. Thank you very much. Thank you. See, we have to understand the difference between parametric tests and non-parametric tests. Whatever definition you have already learned, you just leave it and let us start from today's workshop. See, you know what are the parameters? When some parameters are used in applying any test, it is said to be parametric test. If no parameters are used, it is said to be non-parametric test. So it's a very simple definition. Then obviously the next question triggered in your mind is, what is a parameter? You might have studied from the very beginning measures of central tendency and measures of dispersion. In the case of measures of central tendency, you would have studied mean, median, mode, geometric mean, and harmonic mean. In the case of measures of dispersion, range, interquartile range, quartile deviation, mean deviation, and standard deviation. Of all these measures, we call mean, standard deviation, and variance as the major parameters that are used in applying tests of hypothesis. So these parameters are used in the case of parametric tests. Any of these parameters like mean or standard deviation or variance. What is variance? Variance is the square of standard deviation. Variance is the square of standard deviation, that's all. Okay. Now, come to the other differences. If you are particular about applying parametric tests, the condition is you have to check whether the data are normally distributed or not.
So we can't hear you.
Not audible, sir.
Am I audible now?
Yes, sir. Now you're audible, sir.
Okay. Thank you very much. Thank you. See, we have to understand the difference between parametric tests and non-parametric tests. Whatever definition you have already learned, you just leave it and let us start from today's workshop. See, you know what are the parameters? When some parameters are used in applying any test, it is said to be parametric test. If no parameters are used, it is said to be non-parametric test. So it's a very simple definition. Then obviously the next question triggered in your mind is, what is a parameter? You might have studied from the very beginning measures of central tendency and measures of dispersion. In the case of measures of central tendency, you would have studied mean, median, mode, geometric mean, and harmonic mean. In the case of measures of dispersion, range, interquartile range, quartile deviation, mean deviation, and standard deviation. Of all these measures, we call mean, standard deviation, and variance as the major parameters that are used in applying tests of hypothesis. So these parameters are used in the case of parametric tests. Any of these parameters like mean or standard deviation or variance. What is variance? Variance is the square of standard deviation. Variance is the square of standard deviation, that's all. Okay. Now, come to the other differences. If you are particular about applying parametric tests, the condition is you have to check whether the data are normally distributed or not.
Sir, sorry to disturb you, sir.
Yes.
Sorry, screen is not sharing, sir.
Screen not shared.
Yes, sir. Either
Just
photos or
just after giving introduction, let me share the screen. Okay. Right. So when you are particular about sharing, you are about applying the parametric test, there is a condition that the data should be normally distributed. If the data are normally distributed, then only you can apply parametric tests. If the data are normally distributed or not normally distributed, irrespective of whether the data are normally distributed or not, you can apply non-parametric tests. So the condition is applicable only for parametric tests. Okay. Then the other condition is regarding the variables. You know, we have two different types of variables. That is parametric tests, variables, independent variable and dependent variable. What is dependent variable? A dependent variable is dependent on another variable. But in the case of independent variable, it is not dependent on any other variable. Rather, it is influencing other variables. Okay. So what is dependent variable? What is independent variable? Okay. Then regarding the data type, there are three types of data. Number one, nominal data. Number two, ordinal data. And number three, scale data. What is nominal data? See, we collect data from the respondents. It is entered in the software. We are coding the data. Like for gender, we have categorized the gender into male and female. We are codifying male and female like 1 for male, 2 for female, or 1 for female or 2 for male, like that. Here, that 1 for male, 2 for female, or 1 for female and 2 for male are just indicators. These numbers are assigned. These numbers are assigned. They are not having any real values. They are having no real values. It is just assigned. Just for identification, we are assigning numbers. If you interchange the numbers, there will be no impact. Like, as I told you, 1 for male, 2 for female, or 1 for female, 2 for male. There will not be any change in the analysis, in the results of the analysis. So we call it as nominal data. That variable is called as nominal. Then come to ordinal. Ordinal is also nominal, but the thing is, there is an order. Based on that order only, we are assigning the numbers. Like ranking questions are there. Problems are ranked. First problem, second problem, third problem, fourth problem, fifth problem, like that. If something is ordered, it is said to be ordinal. Similarly, in the case of Likert scale, we are using 5-point scale. There also we are assigning numbers. 1 for strongly disagree, 2 for disagree, 3 for neutral, 4 for agree, 5 for strongly agree, like that. Here also we can change the numbers as well, but order cannot be changed. So we call it as ordinal number. Suppose we are collecting the real values, like actual age is collected, actual income is collected, actual experience is collected, marks are collected. It is said to be the scale data. So there are 3 different types of data, 2 different types of variables. Okay. For applying parametric tests, the condition is that the dependent variable must be scale data. The dependent variable must be scale data. So with this introduction, let us go to the parametric tests. What are the different types of parametric tests? Sagar, you can stop sharing. I can start.
Yes, sir.
Thank you. Yeah. These are the data given to you. Okay. Is it visible?
Yes, sir.
It's visible, sir.
Okay, thank you. Right. What are the parametric tests? Don't bother. Very simple again. There are only two categories. Fundamentally, we have two categories. One is t-test and another is ANOVA. One is t-test and another is ANOVA. The t-test is again classified into three. That is one sample t-test. One sample t-test. Number one sample t-test. Number two, independent samples t-test. Number two, independent samples t-test. And number three, paired samples t-test. So there are three types of t-tests. One is one sample t-test. Second one is independent samples t-test. Third one is paired samples t-test. That's all. Regarding the ANOVA, it is divided into two types. Number one-way ANOVA, and number two-way ANOVA. That's all. One-way ANOVA and two-way ANOVA. So there are 5 basic parametric tests. Number one sample t-test. Number two, independent samples t-test. Number three, paired samples t-test. One-way ANOVA and two-way ANOVA. That's all. Let us see one by one. See, this is one sample t-test. You have to understand where should we apply a particular test. Under which circumstance one sample t-test is to be applied. I have already told you, no, for applying parametric tests, there are two basic conditions. Number one, the data should be normally distributed. Number two, the dependent variable must be scale data. The dependent variable must be scale data. Okay. See, we are collecting a sample. We are collecting data from sample respondents. Maybe 20 samples, 25 samples, or 30, like that. Or in consumer studies, we are collecting 200 samples or 300 samples. Okay. We are collecting the demographic profile also, like age, gender, educational qualification, marital status, income, occupation. No. So that kind of variables are used to collect the data. These variables are grouped or divided into subgroups. Like gender is divided into male and female. Age group may be divided into up to 20 years, 20 to 40 years, 40 to 60 years, and above 60 years, like that. Marital status, married, single, like that. Educational qualification also classified into up to school level, UG level, PG level, others like that. Here, in the case of gender, we have divided the gender into two categories or two groups, like male and female. In the case of marital status, we have divided it into married and single. So there are only two categories. Then nature of family, joint family, nuclear family. Again, there are only two categories. In the case of age, I told you no, just for example, less than or up to 20 years, 20 to 40 years, 40 to 60 years, above 60 years. How many categories are there? 4 categories are there. Suppose area of residence, rural, urban, semi-urban. There are 3 categories. Occupational status, employed, businessman, professional, student, housewife, farmer, like that. So more than 5 or 6 categories. Income up to 10,000, 10,000 to 20,000, 20,000 to 30,000, above 30,000 like that. So here, in the case of gender, there are 2 categories. In the case of marital status, there are 2 categories. In the case of nature of family, there are 2 categories, nature of family or type of. For all the other variables, we have classified into more than 2 categories, that's all. That is what we have to understand. So how many categories are divided for a particular variable? So that is one of the things to be considered for selection of a particular test. Sometimes we will not divide the sample respondents like male, female, married, single, like that. We have not divided them. Instead, if they are taken together as a single sample, so no categorization is made. If no categorization is made, it is called one sample. It is called one sample. In the case of gender, I told you no, 2 categories. The parametric test, I told you there are 2 types of parametric tests. One is t-test and another is ANOVA. For applying t-test, the categorization must either be single or 2 groups. Only 2 groups. 1 group or 2 groups. So we can say that up to 2 groups. Up to 2 groups. If the independent variable is divided up to 2 groups, then we can apply t-test. If the independent variable is divided into more than 2 groups, if the independent variable is divided into more than 2 groups, then we can go for ANOVA. That's all. So the difference between t-test and ANOVA is, in the case of t-test, the independent variable is either taken as a single sample, one sample, or it is divided into 2 groups. That's all. If more than 2 groups are divided, then we have to go for ANOVA. That's all. Okay. Right. Now, if the independent variable is taken as one sample and the sample parameter or the sample mean is compared with the population mean. If it is compared with the population mean, the screen is same See, I'm explaining. No screen is changed. Okay. After explaining, let me change the screen. Till then, you just view what problem is given and you just listen to me what is the aspect to be considered before selection of a tool. Okay. So here, if the sample respondents are not divided into groups, they are taken as a single sample. And the sample mean is compared with the population mean. In that case, we have to apply one sample t-test. So there are three types of t-tests. Number one sample t-test. Number two, independent samples t-test. And number three, paired samples t-test. In the case of one sample t-test, the whole sample is considered as one sample. Sample mean is compared with the population mean. Then we have to apply one sample t-test. If the sample is divided into two groups, like male and female, boys and girls, married and single. So the independent variable is divided into two groups only. In that case, we have to apply independent samples t-test. Independent samples t-test. Right? Then, so this is the case of applying independent samples t-test. See, this is the dependent variable. It is a scale data. That is number of journeys is the dependent variable. It is scale data. Name of the cab is the independent variable. It is divided into two groups only, like Ola and Fast Track. So we apply independent samples t-test. Then, in the case of paired samples t-test, in the case of paired sample t-test, see here, there is only one sample again, but the data are pertaining to two different periods, like before and after, pre and post. Like that, if data are collected for two different periods from the same sample, the sample is not divided into groups. They are considered as a single sample or one sample. In the case of one sample t-test, we had one sample, one data. One sample, one data. In the case of independent sample t-test, we had two samples, one data. Two samples, one data. In the case of paired samples t-test, one sample, two data. That is the difference. One sample, one data means one sample t-test. Two samples, one data means independent sample t-test. One sample, two data means paired sample t-test. That's all. Okay, right. Now let us go to the problem. Take the first problem. What is it? Look at this. St. Joseph College has conducted a coaching class for bank exam. The overall average marks obtained by the students is given, that is 150. Overall average mark. That is the population mean. Overall average mark obtained by all the candidates. So it is the population mean. Then the college says the students or the candidates who attended coaching class in our college have performed better than the overall average of all the candidates. So they are claiming that we are the best coaching center. Like that, they are claiming. So our requirement is the data relating to 25 candidates who attended coaching class in that particular college. The data are given, marks obtained by them are given. Then you are required to test whether the college, the claim of the college is correct or not. That is the question. So here 150 is the population mean that is given. 150 is the population mean. Population mean is given. Then we are required to check whether the SJC candidates have performed better than the overall average of all the candidates. That's all. So here we are not classifying. We are not classifying the sample respondents. They are taken as a single sample. Am I audible now?
Yes, sir, you're audible.
Okay. Then why there is a message from some of the participants?
Not a problem.
If somebody is not able to listen or hear, you just check your speaker or mic. Okay. Right. So here, population mean is given. A sample data for 25 candidates are given. Whatever it is, first of all, we have to write the hypothesis. Once after having understood the problem, we have to write the hypothesis. Number one, null hypothesis. The null hypothesis is nullifying. That is, what is our problem? We have to check whether the St. Joseph College candidates have performed better than the overall average of all the candidates. So there must be a significant difference between the average marks of these students or these candidates and the population mean. That is what the question. So if it is the question, then the null hypothesis is there is no significant difference. There is no significant difference between average marks obtained by the SJC candidates and overall average. So obviously, alternative hypothesis will be there is a significant difference. That's all. So the null hypothesis can be taken as population mean is equal to sample mean. Population mean is equal to sample mean. That is why we have written that there is no significant difference. That's all. Okay. Now let us go to the analysis. So this is the data set given to you. You might have received the data, right? See, in the menu bar, we have analyze. We have a button called analyze. The sixth button from the left or sixth menu is analyze. So select analyze. There appears a drop down menu like this. In this, go to the fourth one, that is compare means. Compare means. Then a sub window appears. In that window, you can find means, one sample t-test, independent samples t-test, paired sample t-test, and one-way ANOVA. One-way ANOVA. So here, the question is, we have to test whether this particular sample is better than the population. So one sample t-test. We have not classified them. Boys, girls, first year, second year, and third year, like that. We have not categorized them. So only one sample. So we go for one sample t-test. That's all. So select one sample. You can find a window like this. What is the variable here? Marks obtained. Marks obtained by them is the variable. So that is given in scale data. Marks mean scale data. If it is given as rank, it is ordinal data. Here marks are given. So it is scale data. So marks obtained is the test variable. So we can select this. See, either you can drag it to the right hand side, or you can simply select it and press the right arrow. It will be brought here. Okay. Then please don't forget to enter the test value. Many scholars fail to enter the test value here. What is the test value? That is the population mean. What is the population mean here? 150. So here we have to enter 150. Without forgetting, we have to enter 150. That's all. So we bring the test variable here and we enter the test value, then press OK. So this is the result of one sample t-test. See, there are two tables given. In the first table, descriptive data given, and in the second table, t-test results are given. See here, in the first one, number. How many candidates were there? 25 candidates. So that is what given here in the number. Then mean, average marks of the 25 candidates are given. Then its standard deviation is given. Standard error is also given. Okay. Now come to the second table. T value is given. Degrees of freedom is given. Then P value is given. This is the P value. Significant value is the P value. Then mean difference. Then 95% confidence interval difference. Upper limit, lower limit. What are the things we have to consider here? We have to take this one. That is, P value is to be taken into account. What is the P value here? 0.019. P value here is 0.019. Okay. Now we have to understand the level of significance. The level of significance. What is the level of significance? Normally, we take 5% level of significance. So that is the normal level of significance taken in all the cases. If we are very strict, then we can go for 1%. But generally, in most of the cases, not in most of the cases, in almost all the cases, we are taking 5% level of significance. Okay. 5% means 0.05. It is not 0.5. Understand? 0.05. Okay. What is P value? P value is the probability value. P value is the probability value. What is probability? Probability is chance of happening. Probability means chance of happening. Okay. What is the chance here? Here, the P value indicates the probability of accepting the null hypothesis. Probability of accepting the null hypothesis. What is the level of significance? 5%. That is 0.05. 0.05. Okay. 0.05 is the level of significance we are considering for the test. Here, the P value relating to the data is ascertained to be 0.019. Is it greater than 0.05 or less than 0.05? It is less than 0.05. It is less than 0.05. If it is less than 0.05, there is a lesser probability of accepting the null hypothesis. If the p-value is less than 0.05, the possibility or the probability of accepting the null hypothesis is less. If it is less, then we have to reject. So what we have to understand is, if the p-value is less than 0.05, if the p-value is less than 0.05, the null hypothesis should be rejected. What is the null hypothesis here? There is no significant difference. There is no significant difference. Why the null hypothesis is rejected? The p-value is less than 0.05. This is the p-value. This is the significant level. It is less than 0.05. So if the p-value is less than 0.05, that is less than significant level, then the null hypothesis is to be rejected, because the probability of accepting the null hypothesis is less. So if the null hypothesis is rejected, automatically the alternative hypothesis is accepted. What is the alternative hypothesis? Just opposite to the null hypothesis. What is it? There is a significant difference. See, the question is not about just a difference. Whether there is a difference or not is not the question. The question is whether the difference is significant or not. That is what the question. So here it is proved that there is a significant difference. There is a significant difference. Okay. From that, how to conclude? What is our question? You are required to test whether SJC candidates have performed better than the overall average. Whether the population mean is greater than whether the sample mean is greater than the population mean. Okay. Here, what we have obtained, p-value is less than 0.05. So null hypothesis is rejected. Alternative hypothesis is accepted. So there is a significant difference. Our question is whether these candidates have performed better. For that, we have to check the first table. In the first table, look at this. We have the sample mean. The sample mean has been computed. So what is the sample mean here? Sample mean is 166.84. 166.84 is the sample. What is the population mean? It is 150. Population mean is 150. So the mean difference is, that is the difference between population mean and sample mean. Population mean and sample mean. Population mean 150, sample mean 166.84. So the mean difference is 166.84 minus 150. The mean difference is 16.84. Our question is whether the population, sample mean is greater than the population mean. Yes, because sample mean is 166.84. Population mean is 150. Mean difference is positive 16.84. Sometimes if the sample mean is 150 and the population mean is 166.84, then also there is a significant difference, but the performance of these candidates are not better. Understand? See, whether the difference is significant or not, one question. The second question, whether the sample mean is greater than the population mean. Here, from the p-value, we have understood that there is a significant difference. From the sample mean and population mean, the mean difference is computed, and from that, we have understood that sample mean is greater than the population mean. Therefore, it is concluded that SJC candidates have performed better than the overall average of all the candidates appeared in the bank exam. That's all. So this is the case where we have to apply one sample t-test. And this is the procedure how to apply. See, let me repeat once again. Analyze, compare means, then go to one sample t-test. Here we have to select the marks as the test variable. Then here we have to enter the population mean. Then click OK. We'll be getting the result. So that is what we have obtained from the analysis. See here, sample mean 166, population mean 150, p-value 0.019, mean difference 16.84. That's all. So shall we move on to the next problem? Second case, independent samples t-test. Independent samples t-test. I told you, no, there are two groups and one data. One group and one data means one sample t-test. Two groups and one data means independent sample t-test. One sample, two data means paired sample t-test. That's all. See here, look at the independent variable, name of the cab operator. That is divided into two, Ola and Fast Track. Number of journeys booked is the dependent variable. That is given as a scale data. See, during the COVID-19 pandemic period, some 30 cab operators were surveyed, and number of journeys booked during the pandemic period. First cab operator said, I have got 225 bookings. He belongs to Ola. Second one is also Ola. He said, I had 300 journeys. 300 journeys. Third one, Fast Track. He said, I had 175. Fourth one, Ola. He said, I had 125. Like that, we have collected data from 30 operators or 30 drivers. Okay. Now the question is, can you conclude that Ola has got more bookings than Fast Track? Whether Ola has got more bookings than Fast Track? Okay. I told you, no. First of all, we have to write the null hypothesis. We have to write the null hypothesis. What is the null hypothesis? There is no significant difference. There is no significant difference between number of journeys booked by Fast Track and Ola during the COVID-19 pandemic period. Obviously, alternative hypothesis, there is a significant difference between the number of journeys booked by Fast Track and Ola during the COVID-19 pandemic period. So in notation, we can say null hypothesis equal to, that is sample 1 mean is equal to sample 2 mean. Sample 1 mean equal to sample 2 mean. So we have to compute the mean of Ola and Fast Track. That's all. Now let us go to the analysis. See here. Again, go to analyze. Then go to compare means. Then select independent samples t-test. Earlier we selected one sample t-test. Now we have to select independent samples t-test. Okay. Then here, what is the test variable? Number of journeys. Because our question is whether Ola has got more bookings. Whether the Ola has got more bookings. So the test variable is number of journeys booked. Earlier, there was only one data, one sample. But here, the sample, number of sample is 2. We are grouping into 2. So what is grouping variable? Name of the cab operator is the grouping variable. Then a button is enabled, that is define groups. How many groups are there? 2 groups. Group 1 is 1 and group 2 is 2. Then continue. See here, while coding, we have given like this. 1 for Ola, 2 for Fast. So here, define groups, group 1, 1, group 2, 2. Even we can change it as 1 for Fast Track and 2 for Ola. No issues. Because it is a nominal data. So here, let me repeat. Analyze, compare means, independent samples t-test. Here, this is the variable box, variables in the data set, and this is the test variable. Here, in our problem, number of journeys booked is the test variable. Then grouping variable is the name of the cab operator. After that, we have to define the groups. Group 1, 1, group 2, 2. That's all. Then continue. See here, OK button is not enabled. If you click continue, then it will be enabled. Look at this. I am clicking continue. Yes, it is enabled. Now click OK. We can get the result. We have got, once again, we have got 2 tables. Table 1 and table 2. Table 1 descriptive statistics and table 2 is the t-test results. Here it is divided into 2 columns. Levant's test for the equality of variances and t-test for equality of means. What we have done, we have compared the means. So let us not take this result. So let us take this part only. That is t-test for equality of means. The results are given in 2 rows. Already 2 columns. We have left the first column. And for the second column, the results are given in 2 rows. Look at this. Equal variances assumed, equal variances not assumed. I have copied down here and pasted in the Word document for your easy understanding. Now we leave it. This is not considered. This is not considered because it is test for equality of variances. We are considering for test for equality of means. So let us take this. Here the results are given in 2 rows. Number 1, equal variances are assumed, equal variances are not assumed. I told you what is variance. Variance is the square of standard deviation. Variance is the square of standard deviation. See here, equal variances are assumed. If the variances are equal, then the standard deviation also must be equal. See here, standard deviation for Ola is 65.876. For fast track, it is 36.956. So these standard deviations are not equal. If standard deviations are not equal, the variances are also not equal. So we have to leave this column also. I mean this row also. So what result we have to consider is this one. This one alone we have to consider. Equal variances not assumed. Again, t value, degrees of freedom, p value, then mean difference. See what is the p value here? P value is 0.000. What is level of significance? Normally we take 5% level. So it is 0.05. I told you in a strict manner, it may be taken as 1%. Even though we are checking for 5% level of significance, based on the probability value obtained, let us give the result as whether it is significant at 5% or significant at 1%. First, we check whether this is less than 0.05, yes. Whether it is less than 0.05, yes. Then we can easily say that the result is significant at 5%. But while checking the other decimals, it is found that it is even less than 0.01. It is even less than 0.01. Then we can say that the difference is significant at 1%. It is significantly different at 1% level. So what is our question? Whether Ola has got more bookings than fast track. For that, first we have to prove whether the difference is significant or not. Yes, it is proved that it is significant. The difference is significant. Then whether Ola has got more bookings or fast track has got more bookings. For that, we have to compare the means. Look at it. Earlier in the case of one sample t-test, we compared the sample mean with the population. So the null hypothesis was population mean equal to sample mean. Here, what is the null hypothesis? Sample mean, sample 1 mean equal to sample 2 mean. So here we have to compare sample 1 mean and sample 2 mean. What is sample 1 mean? 250.28. What is sample 2 mean? 174.58. So what is the mean difference? Look at here, 75.694. 75.694 is the mean difference between Ola and fast. So here, Ola's mean bookings was higher. Comparatively, it is far better than the fast track. The mean value of fast track is just 174.58, whereas the mean value of Ola is 250.28. See the difference? 75.69. So obviously, Ola has got more bookings. So that is the conclusion. It is concluded that Ola has got more bookings than Fast Track during the COVID-19 pandemic period. So this is what independent samples t-test. Independent samples t-test. So in the case of one sample t-test, one sample, one data. In the case of independent sample t-test, two samples, one data. So next one, paired samples t-test. Next one, paired samples t-test. Here, one sample, two data. One sample, two data. If your study is like this, then you have to apply paired samples t-test. That's all. So 25 families have been taken in a particular place, and their average monthly grocery purchases before lockdown and after lockdown have been given. Average grocery purchases before lockdown and after lockdown. If the data is given like this, then you have to apply paired samples t-test. Now the question is, from the above particulars, examine whether the average grocery purchases have been affected due to lockdown. That's all. So the result, the question is whether the purchases have been affected by lockdown, due to lockdown. That is a question. So what is the hypothesis? No significant difference between the average purchases before and after lockdown. See how we are writing the null hypothesis for independent sample t-test. It is based on the samples. No difference between journeys by fast track and Ola. Here, the null hypothesis is based on the data, that is before and after. Before and after. So, alternative hypothesis, there is a significant difference. There is a significant difference. Again, in notation, H naught equal to sample mean, that is before mean and after mean. That's all. Before mean and after mean. Now we will go to the data. Once again, analyze. Once again, compare means. Now we have to select paired samples t-test. We have to select paired samples t-test. Okay. This is the window for paired samples t-test. Here, what are the variables? Average grocery purchase before lockdown. Average grocery purchases before lockdown. And average grocery purchases after lockdown. Okay. If you select the data or the variables are automatically paired like this. It is not 1 and 2. Variable 1 and variable 2 are paired. Here there is no grouping variable because there is only one sample. So no grouping variable. Straight away we can click OK button. These are the results we can obtain from the paired samples t-test. Table 1, once again, descriptive data. Table 2, correlation results. And table 3, t-test results. Let us start with the third table as usual. Here, look at this t-test t-value, degrees of freedom, and p-value. What is the p-value here? 0.796. Every time after applying a particular test, we get the results. From the results, we have to check whether the p-value is less than 0.05 or greater than 0.05. Here, the p-value is 0.796. It is greater than 0.05. If it is greater than 0.05, it is greater than the level of significance. If it is greater than the level of significance, the probability of accepting the null hypothesis is greater. In the early two cases, the p-value was less than 0.05. If it is less than 0.05, the probability of accepting the null hypothesis was less, so we rejected the null hypothesis. If the null hypothesis is rejected, automatically alternative hypothesis is accepted. Here, the p-value is greater than 0.05. If it is greater than 0.05, the possibility of accepting the null hypothesis is greater. So what is the conclusion or what is the decision? We have to accept the null hypothesis. We have to accept the null hypothesis. P-value is greater than 0.05. So we accept the null hypothesis. What is the null hypothesis? There is no significant difference between the average grocery purchases before and after lockdown. If the difference is not significant, automatically we conclude that the purchases are not affected by lockdown. Is it not? If the difference is significant, then we can say that the purchases are affected by the lockdown or due to lockdown. But here the result says that there is no significant difference. If the difference is not significant, we can come to the conclusion that their purchases, their grocery purchases of the selected 25 families are not affected due to lockdown. Once again, even though we have got the results, we can compare the mean values. Just for the sake of understanding, we can compare. Average purchases before lockdown, 1617.6. After lockdown, it is increased, 1632.60. What is the mean difference? Mean difference is not greater. Okay. Here it is not given. Okay. Just 15. 1617.6 and 1632.6. So just 15 rupees are different. So it is not a greater difference. So we come to the conclusion that there is no significant difference between the average monthly grocery purchases before lockdown and after lockdown. Or otherwise, we can say that the lockdown has not affected the monthly purchases of the selected 25 families because there is no significant difference between the average monthly purchases before lockdown and after lockdown. That's all. So this is about the paired samples t-test. So far we have discussed about 3 tests. These are coming under the category or under the family t-test. So parametric test is divided into 2 families. One family is t-test, another family is ANOVA. In the t-test family, there are 3 tests. One sample t-test, independent sample t-test, and paired sample t-test. In all the cases, we should understand that the dependent variable is a scale data. Dependent variable is a scale data. So here, let us have a comparison. Just for your understanding, I'm giving you the comparison. Here, one sample t-test. In the case of one sample t-test, there is only one sample, one data, dependent variable is a scale data. Then independent samples t-test. There are 2 samples, one data. Dependent variable is scale data. Then paired samples t-test. There is only one sample, 2 data, scale data. That's all. So here, in any way, number of samples should not exceed 2 for the t-test. For the t-test, the number of sample should not exceed 2. Either it may be 1 or it may be 2. So these are the conditions for t-test. One sample t-test, independent sample t-test, and paired samples t-test. Okay. Then we will go to the another family, that is ANOVA. ANOVA is the another family of parametric tests. In the ANOVA family, there are again 2 tests, one-way ANOVA and two-way ANOVA. One-way ANOVA and two-way ANOVA. One-way ANOVA and two-way ANOVA. Here, one more. Number of independent variables. Number of independent variables. Okay. Then here, one way ANOVA and two way ANOVA. Number of samples. Number of samples more than 2. Here also it is more than number of samples more than 2. Number of independent variables 1. In two-way ANOVA, 2 or more. 2 or more. Once again, number of data 1. Dependent variable scale data. So these are the things we have to keep in mind. That's all. So for applying t-test or ANOVA, what is the main basis? Number of samples is the main basis. Look at this. Here it is 1, 2, 1. In both the cases, it is greater than 2. Greater than 2. Whether it is one-way ANOVA or two-way ANOVA, it is based on number of independent variables. If only one independent variable is there, then we have to apply one-way ANOVA. If there are more than 2 or more independent variables, we can go for two-way ANOVA. Number of data 1. Then dependent variable scale data. That's all. That's all. Right. Now we'll go to the one-way ANOVA. There are 3 food delivery service providers in Bengaluru: Swiggy, Zomato, and Uber Foods. The overall satisfaction of 30 customers towards the services provided by them was obtained. The overall satisfaction scores are given. Look at this. Scores are given. See, some parameters are there. Based on that, the marks are, the scores are calculated. And we are not given the methodology of calculating. We are given the scores only. Okay. So here, what I told you, one-way ANOVA means number of samples must be greater than 2. Here, there are 3. That is Swiggy, Zomato, and Uber. So greater than 2. Okay. Then independent variable, only 1. Yes. That food delivery service provider is the only one independent. Then data 1. What is it? Satisfaction score. That's data should be scale data. Data should be scale data. Yes. Here is also, it is given as overall satisfaction scores. Now the question, you are required to examine whether there is any significant variation in the overall satisfaction of customers in accordance with food delivery service providers. So there are 3 service providers, Swiggy, Zomato, and Uber Foods. The customers are there. There are 30 customers. We have selected 30 customers. And they belong to different service providers. See, the first one is always using Swiggy. And he said, I have given 63 marks. Second one using Uber Foods. He said 58 marks. Zomato, third one using Zomato. He said 49 marks only. Fourth one Swiggy, 71. Fifth one also Swiggy, 68. Sixth one Zomato, 59 marks. Like that, the marks are given. Marks awarded by 30 customers are given. Now we are required to test whether there is any significant variation in the overall satisfaction of the service providers. So number of samples, 3, that is more than 2. Number of independent variables, that is only 1. Number of data, only 1. Data is scale data. So we have to apply one-way ANOVA. One-way ANOVA. Again, let us start with the null hypothesis. What is the question? Is there any significant variation? So here there is no significant variation. Then alternative hypothesis, there is a significant variation. There is a significant variation. So how many groups are there? 3 groups are there. 3 groups are there. So H0 is equal to sample 1 mean is equal to sample 2 mean equal to sample 3 mean. Sample 1 mean equal to sample 2 mean equal to sample 3 mean. That is what the null hypothesis. There is no significant variation. There is no significant variation. So here it is one-way ANOVA. ANOVA means variance. So we are not comparing the mean. We are comparing the variance. Anyhow, the result will be based on mean only. Comparing the variance, we are deciding whether there is a significant variation or not. But the difference is measured in terms of mean once again. For decision making, we are using variance. For final conclusion, we are using the mean. So let it be like this. Sample 1 mean equal to sample 2 mean equal to sample 3 mean. Now let us go to the analysis. Analyze, compare means, one-way ANOVA. Analyze, compare means, one-way ANOVA. See here. This is independent list. This is factor. Independent. Dependent. What is dependent? Overall satisfaction score is the dependent. What is the factor? Food delivery service provider is the factor. So dependent is the overall satisfaction score. Factor is the food delivery service provider. One of the participants has asked to explain about one-tiled and two-tiled. Please don't get confused with one-tiled, two-tiled, and one-way 2V. See here, if you draw a graph, there are two tails. 0 is the centroid. Left side, x-axis, see for example, x-axis, left side negative values are there, right side positive values are there. In the case of one tail, only one side is considered. That is either positive side or negative side is considered. In the case of two tail, both the tails are considered. Both negative and positive sides are considered. That is said to be two-tailed test. But here we are using one way and two way. What is the difference? I told you no. In the case of one way, we have only one independent variable. Only one independent variable. See here. For two way, we have two or more independent variable. What is the independent variable here? Food delivery service provider is the only one independent variable. So now let us come to the analysis. Let me repeat once again. Analyze, compare means, then one way ANOVA. What is the dependent? Overall satisfaction. What is the factor? Food delivery service provider. Then just click OK. Now we can get only one table. Unlike in the case of t-test, we have got only one table. That is ANOVA results. See, look at here. Squares, degrees of freedom, mean square, F value. In the case of t-test, we got the t value. But even though we get the t-test results, I mean t value, we have taken only p value. Similarly, here also, we have to take the p value. What is the p value? 0.093. Whether 0.093 is greater than 0.05 or less than 0.05. It is greater than 0.05. It is greater than 0.05. Since p value is greater than 0.05, it falls in the acceptance region. It falls in the acceptance region because there is a greater possibility of accepting the null hypothesis. So it is accepted. If it is accepted, what does it mean? There is no significant variation in the overall satisfaction. Okay. So based on variance, a decision is made that there is no significant variation. Okay. Can you conclude or can you say which of these service providers like Swiggy, Zomato and Uber, there are three service providers. Out of these three, who has satisfied the customers more? The question is not about the difference. The decision what we have made is not about the variation. It is about the significant variation. That means there may be a difference. There may be variation, but it is not significant. So obviously we have to understand there is a variation. There may or may not be a variation in the satisfaction score of service providers. Based on the average score, that is why we have taken like this. Sample mean 1, sample 2 equal to, sample 2 mean equal to, sample 3. But we have got only one result. Here mean value is not available. So how to get the mean value? How to get the mean value. Once again, go to analyze, compare means. Now go to means. Earlier we have not used this option. Now we are using this. Now we have got this window. Dependent. What is the dependent? Overall satisfaction score. What is independent? Food service delivery provider. Yes. See here. The overall scores have been obtained. We have to divide it. Where means go to the options. Mean, number of cases, then standard deviation. Or sometimes you can get the minimum, maximum also. You got it. Swiggy 60.08. Uber Foods 50.09. Zomato 56.14. So which is the greatest? Swiggy 60.08 is the greatest. So obviously we can say the satisfaction of customers, of Swiggy customers is more than the customers of others. Which service provider has given the lowest satisfaction to their customers is none other than Uber Foods, because the mean score is 50.09. Even though we have got the result that there is no significant variation. There is no significant variation, but based on these mean values, we can say that satisfaction of Swiggy customers is more than the customers of others. So this is what about one-way ANOVA. Then we go to the two-way ANOVA. Yeah. St. Joseph Papers Limited sells its products through dealers, distributors appointed in 4 different zones: East, West, North, and South. Annual turnover of 30 of its dealers and distributors are given. Okay, look at this. See, this is independent. This is also independent. This is dependent. What we have said, in the case of one-way ANOVA, there is only one independent variable. In the case of two-way ANOVA, 2 or more independent. 2 or more independent. Dependent only one data. Here, look at this. Type of retailer is one independent. Zone is another independent. Both are nominal data. Annual turnover is the only data. That is dependent variable. That is scale data. So we apply two-way ANOVA. The question, you are required to examine whether there is any significant variation in the annual turnover of the company according to the retailer and zone. Retailer and zone. So together, we have to check for both retailer and zone. Okay. For that, we have to write three null hypotheses. Three null hypotheses. Number one, there is no significant variation in the annual turnover according to retailer. Number two, according to zone. Number three, according to retailer and zone. Retailer and zone interaction. So obviously there will be three alternative hypotheses. There will be three alternative hypotheses. That's all. There are two independent variables, one dependent variable. Dependent variable is scale data. Regarding the independent variables, type of dealer and zone. Type of dealer, there are only two groups. Okay. For ANOVA, I said there should be more than two groups. But here we have more than two groups. In the case of zone, we have four groups. East, west, north, south. So four groups are there. So we can apply one way, two-way ANOVA. We can apply two-way ANOVA. We already formulated the hypothesis. Now we'll go to the analysis. Go to analyze. Compare means okay, over means one sample t-test, independent sample t-test, paired sample t-test, one-way ANOVA, over. What about two-way ANOVA? Go to the next one, general linear model. Go to general linear model. Then select univariate. Univariate means only one dependent variable. Only one dependent variable. So univariate. We select that. See, look at this. Dependent column is given. Dependent variable. See, in the case of dependent variable, the box is very little. The box is very little. So in that box, only one dependent variable can be accommodated. Look at this. The size of dependent variable box, there is only one variable that can be accommodated. Here, several boxes are given. Random factors, covariate, WLS weight, fixed factors, and different models are there. At the beginning level, at the level 1, we are using the fixed factors only. We are using the fixed factors. What is the dependent variable? Whether there is any significant variation in the annual turnover. So annual turnover is the dependent variable. So annual turnover is the dependent variable. What are the independent variables? Type of retailer and zone. So they are taken as fixed factors. Type of retailer and zone. They are taken as fixed factors. Here there is no need for specification of any model. No need for options, also actors and all. Just click OK. Just click OK. In our sample, the retailers are divided into two groups, dealers and distributors. In our sample, they are equally divided. Dealers, 15 dealers and 15 distributors. That may also differ. That may or may not differ. They need not be equal. Similarly, zone-wise, there are 8 dealers in the east zone, 7 retailers in the west zone, 8 retailers in the north zone, 7 retailers in the south zone. Here also we have to understand that number of zones, number of retailers in each zone need not be equal. Number of retailers belonging to the type of retailer also need not be equal. So that is what we can understand from this table. Then come to the final result. This is the final result. How many hypotheses we have framed? There are 3 null hypotheses. Null hypothesis 1, there is no significant variation in the annual turnover according to the retailer. See here. According to the retailer. What is the p-value? 0.569. 0.569. It is greater than 0.05. So not significant. Then zone, it is 0.000. So it is significant at 1%. Retailer cum zone, 0.332, greater than 0.05. So not significant. So these are the results of this two-way ANOVA. See here, the turnover may be influenced or may be affected in 2 ways. One way, according to type of retailer. Another way, according to zone. According to zone. Here the result says, according to retailer, it is not significant. According to, but according to zone, it is significantly different. So if it is significantly different, once again, we go to the compare means. Once again, we go to the compare means. Here, annual turnover is the dependent list. Then zone, because the result says that there is a significant difference in the annual turnover. That is the dependent variable. Annual turnover according to zone. So we take this like that. So according to zone. What are the options? Mean, number of cases, standard deviation, that's enough. Okay, click OK. Now look at here. The average annual turnover of the retailers in East Zone is 61.3 crores. 61.13. The retailers in West Zone have made an average annual turnover of 28 crores. North Zone, 40.63 crores. South Zone, 80 crores. So which is the highest one? South Zone. South Zone retailers have made the highest average annual turnover. The lowest turnover is given by the retailers in the West Zone. So the best zone is South Zone and the worst zone is West Zone. As a marketing manager, you have to analyze this and you have to suggest the retailers in the West Zone to improve their turnover by adopting the benchmark strategies of the retailers in the South Zone. So what strategies they have adopted? Whether they have made more publicity and advertisement, or whether they have given some promotional measures. So you follow the South Zone retailers. Like that, you have to advise the retailers in the West Zone. So what is the result? Here, no. Since the p-value stating the relationship between type of retailer and annual turnover is greater than 0.05. There is no significant variation based on type of retail. But based on zone, there is a significant difference. There is a significant variation. Once again, with reference to type of retailer and zone, there is no significant variation in the annual turnover. So finally, we conclude that the annual turnover varied significantly among the 4 zones. And based on the average turnover of each of the zones, we conclude that the best zone is South zone and the worst zone is West zone. Others are average because the East zone 61, North zone 40. We can advise the North zone also because they have got the second lowest average annual turnover. That's all. So these are the ANOVA tools, one-way ANOVA and two-way ANOVA. I started with parametric tests and non-parametric tests. If some parameters are used, they are said to be parametric tests. If no parameters are used, it is said to be non-parametric tests. So what is parameter? Mean, standard deviation, and variance. They are called parameters for deciding the parametric tests. Parametric tests are basically divided into 2 families, t-test and ANOVA. T-test is again divided into 3 types. One sample t-test, independent samples t-test, and paired samples t-test. So when should we apply one sample t-test? If there is only one sample and one data. The data is scale data. Then in that case, we have to apply one sample t-test. While applying one sample t-test, we have to compare the sample mean and population. Only here we are using the population mean, or otherwise we are comparing the samples only. So it is obvious that for applying one sample t-test, we need population mean also. We need population mean also. Then only we can apply one sample t-test. If there is only one group or one sample and one data, the data is scale data, we can apply one sample t-test. Then if there are 2 samples and one data, the data is scale data, we can apply independent samples t-test. Then paired samples t-test. Only one sample, but 2 data. Earlier, 2 samples, 1 data means independent sample t-test. 1 sample and 2 data means you have to apply paired samples t-test. In this case also, data is scale data. This is what we have to understand about the situation where we have to apply one sample t-test, independent samples t-test, and paired samples t-test. In all these cases, we can understand that number of samples must be either 1 or 2. If it is more than 2, we can go to the ANOVA. ANOVA family contains 2 tests, that is one-way ANOVA and two-way ANOVA. In the case of one-way ANOVA, there is only one independent variable. And in the case of two-way ANOVA, 2 or more independent variables. But in most of the cases, we have 2 independent variables. Like in this case, type of retailer and zone. Then in both of the cases, there is only one data and the data is scale data. This is a snapshot about understanding the parametric tests, t-tests and ANOVA. So far, we have completed 5 tests today. That is parametric tests we have completed today. And tomorrow, we are going to discuss about the non-parametric tests. With this, I'd like to conclude. I thank Dr. Shekhar for having given wonderful opportunity. I thank all the participants for the patient listening. Thank you, everybody. Now, we have 5 more minutes left. And if you have any doubt, you can unmute your mic and ask, or you can put your question in the chat box. Thank you very much. Thank you, one and all.
Sir, good evening, sir.
Very good evening, madam.
Sir, thank you so much for providing your insight to us, sir. And the session was really very useful. Sir, I have only one doubt, a small clarity I needed, sir. Sir,
Yes, ma'am. Yes.
So in two-way ANOVA, sir, why we wanted to frame a 3 null hypothesis and 3 alternative hypothesis, alternatives, sir, that I'm not
Yes.
getting.
There are 2 independent variables. No. One is type of retailer and another is zone. Sometimes, if it is affected, either it may be affected by type or by zone or maybe by both. That's why we are framing 3 null hypotheses.
Okay,
Okay, madam.
Okay, sir. So usually for two-way means we have to do 3 null and 3 alternatives, sir. Is that the rule, sir? For
Madam, your voice is not audible.
am I audible now, sir?
Yes, madam. Yes.
Sir, I'm asking that if suppose we are going for two-way ANOVA, is it is a rule that we have to frame 3 null and 3 alternative, or it depends upon
If
the
2 independent number of independent variables.
Okay.
Yes.
Okay, sir. Thank you.
Hello, good evening, sir. Hello.
Yes, sir. Good evening, sir. Sir.
Sir, I have
Please.
one doubt, sir.
Yes, sir. Please.
Sir, I took 5 cities samples of medical representatives, sir.
Hello. Sir.
I took 5 cities of medical representative samples, sir.
Okay.
And can I compare by can I use one-way ANOVA analysis, sir, for that?
Hello. Sir, could you repeat the question once again?
Sir, I took 5 cities of medical representatives data, sir.
Okay.
About their opinion about work culture, sir.
Okay.
So can I apply one-way ANOVA test for that comparison, sir, of all these 5 cities data?
5 cities, okay. You can compare. You can have one-way ANOVA. Yes. Because
And
more than two groups. No, you have taken 5 cities. No.
Sir.
So you can apply one-way ANOVA.
Even can I apply chi-square test for this, sir, for the same data?
Very good question. Chi-square test is a non-parametric test. Okay. That we are going to discuss tomorrow. I will let you know tomorrow.
Okay, sir.
Good evening, sir.
Yes, sir. Very good evening.
Sir, my hypothesis is whether free voice calls have significant impact on brand loyalty of any company. Hello. Sir, am I audible?
Sir, what happened?
Yes, sir, my hypothesis. Hello.
Yes.
Sir, my hypothesis is whether free voice calls have significant impact on brand loyalty. Now, brand loyalty I have measured using Likert scale. So, can you suggest a test for the same?
Which one? Hello, sir. Could you please type the question in the chat box?
Okay, sir. I'll type it. Thank you.
Because it is not audible. Any other questions?
Good evening, sir.
Yes, sir. Good evening, sir.
For this program, e-certificate will be provided by tomorrow, right?
Hello, sir.
For this program, e-certificate will be provided tomorrow, right?
Yes,
Yes,
sir.
sir. Yes, sir.
Yes,
That
sir.
you contact Dr. Shekhar.
But certificate will be provided. That is certain. No.
Hello.
Yes.
Sir,
So
good evening,
hypothesis.
good evening, sir.
Yes, sir. Good evening.
Good evening, sir. Sir, I have a small. So, how to
Yes.
calculate this mean population, sir? You are talking about one-way ANOVA, right? In that one-way ANOVA,
Population.
one-way.
One sample
Sorry,
t-test.
one sample t-test. How we get this mean population, sir?
Sir, that we have not calculated. That is
Okay.
given in the problem itself.
It's okay.
Okay.
In case if I'm doing that one,
That's what I told you
how I'm
now.
getting that
We
particular one?
should know the population mean, then only we can apply one sample t-test.
Okay. So condition is if you know the population mean only we can use that particular one.
See, like overall average, no. Huh?
Yes, sir. Yes, sir.
What is the overall average of the whole college or whole department? Like that,
Okay.
there are some data that is based on secondary data only.
Okay.
Okay.
Okay, sir. Okay, sir. I got it. Master. Thank you.
Free
Sir,
voice calls have significant impact on brand loyalty of customers. Okay. How do we measure the impact of free voice calls on brand loyalty?
sorry, sir.
See, you have framed the null hypothesis that free voice calls have significant impact, so that impact on brand loyalty is measured.
Yes.
If it is measured in quantities. See, suppose you have given number of questions to measure the brand loyalty. In your questionnaire, for brand loyalty, you are giving so many questions. See, like for brand loyalty, there are certain characteristics: voluntary, repeated repurchase, then willingness to pay premium, willingness to recommend the product to others. These are the basic characteristics of brand loyalty. Okay, so for that you are giving some 5-point scale like that. Strongly agree, like that. Then you are assigning scores like 5 for strongly agree, 4 for agree, like that. Okay, then you are summing up. I told you no. Voluntary, repeated repurchase. So voluntary, I am purchasing voluntarily. I am repurchasing repeatedly. I am willing to pay premium. I am willing to recommend the product to others. So there are 4 questions. Okay. So 5, 4, 3, 2, 1 you are given. So what is the total mark of each respondent? You are summing up. That is the scale data. Or otherwise, 5-point scale will be ordinal data only. If you get the total score, then only it will be the scale data. If it is scale data, then you can have the parametric test. Then regarding the voice calls, free voice calls, what about your question? Your question is whether you are using free in your plan, whether there are free voice calls or not. If you are asking like that, there are only 2 choices. In that case, if there are only 2 choices, then you have to apply independent sample t-test. Or otherwise, you are giving like number of free voice calls, 0 to 100, 100 to 200, 200 and above. Like that means you can apply one-way ANOVA. Okay, sir.
Yes, sir. Thank you so much.
Thank
Sir,
you, sir.
I have another doubt.
Yes, sir.
Sir,
Yes.
can you just explain me how to check the normality of the sample, sir?
Yeah, normality test is different. That can be tested in different ways. Normality test can be tested in different ways. So once again, you have to go to the analyze, then go to descriptives, then you go to the normality test. For that, you can go to the next point, go to the analyze button. Then you can extract that. Based on that, you can test the normality based on skewness, based on kurtosis, or based on KS test, or based on Sapiro-Wheel test, or based on graphs like histogram and all. Okay. So there are different tests to be used. See, if you go to frequencies, if you go to descriptive tests, statistics, you can find different submenus. Of all these submenus, you have to select the third one, that is explore.
Explore.
If you use that explore option, you can get the results. Okay.
Okay. I'll try, sir. If I have any doubt, tomorrow I'll ask you questions, sir.
Sure. Thank you.
Thank you, sir. Thank you.
Any other questions? Okay, thank you very much. Good night, all of you.
Thank you, sir. Thank you, sir.
Yes.
Thank you for your valuable
Thanks,
time
sir.
to
Good night,
spare with us.
Thank you very
Participants are
much, sir.
requested to tomorrow session onwards. We will expect the same cooperations. Thank you, one and all.
Thank you, sir. Thank you.